and looking at issues of water quality in San Diego, where I live now. San Diego Bay, Mission Bay are dead zones because there's too much nutrients in them. So too many nutrients creates too much algae, which suffocates the water system. There's no oxygen for the fish to survive. And that has negative impacts on birds, that has negative impacts on people, right? So all of these negative cycles keep feeding each other, but restoration has the opposite effect. When you're able to start restoration, it has positive feed loopback cycles, right? So what we decided to do is found a company. Our company is called Ages Inc. We're building projects for the ages, right? We're not talking about 5 years, 10 years. Our hope is that we're looking to the future for the next 100 years or 1,000 years, right? And I know that's hard for us to think about, but me as a young designer, we don't want to just build beautiful buildings like this. You actually have a great experience here at the Polytechnical University. When I was coming up to it, you have an experience as you walk up to the building, right? And what I'm really interested in is those experiences happen in our cities, but what happens if our cities can't survive? What happens if our cities don't have water, right? We have water tanks, right? We start to change the way that our cities look, the way that our cities feel, and sometimes that's not for the better. So if we have these big water crises, what's gonna happen? We're gonna have less energy. These lights are gonna go out, right? So you have these kind of things that start to have impacts on each other. So let's talk briefly. Our company is looking at projects like this, and we started to evolve what we could do in San Diego Bay or Mission Bay. If we can figure out the most polluted water system in the world, that technology can be used anywhere. And that became really an interest. I grew up in Coachella Valley, right about here, and I never heard of the Salton Sea. Why? Because we didn't have education. And education is muy importante, right? Most important thing is to develop your mind. And once your mind is open, then you're able to envision things. That's why I like architecture. You can create something out of nothing, and then you create that space that other people see that vision, and then they go into that space and you change their vision again. So what I'm really excited about and nervous about is there's not vision when it comes to climate change. There's not inspiration. It was about 10 years ago. I'm gonna be 40. I started this project when I was 30 years old, right? Most of you might, that's 10 years from now for some of you, right? You might be 18, 19, 20, 10 years from now you're gonna be 30. What are the contributions that all of us can bring to the table? For me, it is us having a child, right? I have 3 boys now, 12 years old, 10 years old, 7 years old. What can I do to protect their future generations? Big picture, big story, but what I'm really excited about is projects like this can start to change the world and start to have a positive impact. So let's start. Tres Manos, and that's actually the name of the project. We keep that Spanish translation because the majority of this project and the intent of this project is that this doesn't just benefit this area, right? We're not trying to take something from somebody else to benefit somebody else. That's the old way of thinking, right? The new way of thinking is that you benefit them, you benefit them, you benefit the whole system. So we're going to talk about that today. Tres Manos, Salton Sea, Laguna Salada, and the Gulf of California, right? Because you can't take something from the sea and have a negative impact on that. You have to always think, can I have 100% benefit, 200% benefit, 300%? Not, we're going to have a negative impact to get something for somebody else, right? All right, Tres Manos. Okay, we'll go to the next one. What is the water cycle? And we talked a little bit about that. The ocean is a desalinization plant, right? The ocean is making fresh water. How can we create a system that is like that enhances that system? Go to the next one. Water goes up, water comes down, right? What do we see? That this region, the Sea of Cortez, Laguna Salada, Salton Sea, that affects this whole thing, the whole system, right? The Colorado River Basin. Why? because of these different things, right? There's a lot of water that comes and evaporates from this region, and it flies to the east, and that is the North American monsoon. I didn't know any of these things. I just said, we can go to the next. I just started looking at it and seeing when Laguna Salada was full, there was more water in the Colorado River Basin. Is that because there was more water in the Colorado River Basin that Laguna Salada was full? Or maybe that had an impact on why there was more water in the Colorado River Basin, right? So you have these things that you start doing research on. What does it really mean? What is the information providing us that we didn't know before, and how can we apply that? So it was discussed in the last presentation that most of our water comes in the winter months. A lot of our research actually talks about the summer months and the monsoon cycles. That's important, right? If anybody's heard in the last 5, 10, 20 years about a non-soon, that means that a monsoon cycle didn't occur. So non-soons have a negative impact on the Colorado River Basin. So you have less rain, but also less monsoons. They dry out the land, and so when you do have rain, all of that rain washes off down back into the ocean. So you have negative impacts. Then you have more fires, which create more negative impacts. So all of these things are related, but the most important thing is that a lot of this origination occurs in this region, right? What are possible solutions, right? When we looked at the Salton Sea, we looked at the water quality. Very salty. It's about twice as salty as the ocean now, and it's climbing every day. Because fresh water goes into the atmosphere, salt stays behind. What else is there? And it was mentioned previously, there's lots of agrochemicals, PCBs, all of these really not good chemicals that we used to use on agriculture, but all of the new chemicals that we use on agriculture. So you have heavy metals and chemicals. What else do we have in there? We have lots of nutrients. A fish dies in the water, those nutrients stay in the water. Runoff from our farming operations go into the water, that creates algae blooms. That algae becomes nutrients and suffocates the water table. So no animals and no fish are able to survive because of oxygen not being there. You can imagine not being able to breathe, same for fish. So you have 3 big issues. Another big issue, less water, right? That's the biggest issue, right? Is no more water going in there because we're transferring it to urban areas, San Diego, Coachella Valley, Los Angeles. There's a lot of people in all of those cities. I'm one of them. My family's one of them. But also there's a lot of people here in Mexicali, and there's a lot of people in Tijuana, right? So those urban water uses are tied in with also the agricultural uses. But what's the piece of the puzzle is that technology can be an assistant to that, right? When we talk about farming, look at how much farming there is. Lots of farming. To your question before, technology, right? Is there a way, and we actually had a presenter yesterday, to use one technology to reduce water consumption? You can add a chemical to your water and it could potentially have 40% reduction in water usage for agriculture. That big blue pie that we saw in the previous presentation, if you apply one technology, you could have 40% reduction. That's a huge amount of that puzzle, which is 78% agriculture. You just now freed up, right? 34% of that for other uses, water savings, or other projects, right? Other technologies that we'll talk about briefly, and then we'll get into some of the dynamics of what we've been looking at. Ocean water. And I'm gonna say it now, and then I'll probably repeat it at the end, but I'm really excited about one solution to climate change. And you know what that is? Seawater. Everybody thinks climate change, the biggest impact is going to come from ocean water, but maybe that's our biggest asset when it comes to climate change restoration. That's my hope, and that's what I'm seeing, is that you can use ocean water to create fresh water, right? You make this, and you extend this here, and you extend it here. You not only keep these areas full, and you make a lot of water every year, but what else can we use ocean water for? You can use ocean water for seawater agriculture. There's a company, actually my mentor, right? Many of you in this room right now, you might have a teacher that's your best friend that you really look up to, that has taught you a lot. My mentor was an architect, is an architect. His company does seawater agriculture, and they're currently permitting them here in Baja California, and they're currently permitting and building them in the Pacific Ocean. But seawater agriculture is a technology that can be used around the world and around Mexico in arid desert conditions to create food, biofuel, animal feed, building products, right? The whole spectrum of positive feed loopback cycles, right? What is food, right? Shrimp, tilapia, bivalves, oysters, things like that. Those animals make waste, which is nutrients, right? And what do we need in farming operation? You need nutrients. Rather than adding nutrients to your water or your chemicals, you use animals that are edible to create nutrients that go into edible plants that can be used for biofuel, for jet fuel, for oil products, but also animal feed, right? So very important, one piece of the puzzle. If you're able to do that in large regions, what else does that do? That creates more evaporation water, right? So you might take what is here, and it might be 1.2 million acre feet of water that evaporates every year. Salton Sea, another 1.2 million acre feet of water every year. Now you have another 1.2 million acre feet of water every year. And now you have another one, right? So these things start to have positive impacts all the way upstream, right? And then like it was mentioned before, you control that with dams, right? When you have a surplus of water, now we have too much water, you turn the dam and let some water flow out, which helps the river below it, right? Yeah, so what other systems like this can use ocean water? In San Diego, we have SeaWorld. Anybody been to SeaWorld yet? You should, yeah, it's beautiful. As much as so I have conflicting issues with SeaWorld, right? Like,